Hi folks, this is CU speaking again. In order to be able to effectively make that project, that nice project about the helper for 5-second rule, I'd like to clarify some things about the monostable circuits, because for some reason I think they are a bit misunderstood. So for the next couple of videos we're going to deal with a lot of examples about the monostable circuits until I make sure we're going to manage it. Let's start it. As you can see on the screen, in the top we have something very classical, which is what we call astable or flicker, or clock generator, or even oscillator. As long as the power goes on or stays on, the light or whatever is the output you're going to use is switching on, off continuously. You take a look. If I press this button and you watch over here the blue light, take a look what happens. Exactly as on the screen, it stays on for 1.5 seconds and it goes off for 1 second. 1.5, 1 second. 1.5, 1 second. It goes continuously. Why? Simply because as long as the circuit is energized, it generates that kind of signal which is using the inside clock, the internal clock of the PLC as reference. So the timing is very precise, very accurate. This is called the astable, or the flicker, or the clock generator, or simply an oscillator. Now compared to that, if I stop it, compared to that, what is the monostable? As the name suggests, the monostable means whatever you want to control, a pump, a sound, a light, whatever it is. It only has one stable state. Like now, the stable state is off, and it's going to be this white light right here. So the stable state is off. When you trigger this event, this particular event, what's going to happen? The light goes out of the stable state, which is off. It goes on, like right now, if I'm going to press the button, okay? It goes on, and it stays on for a limited time. In that situation here is about 10 seconds. It's not about, it's exactly 10 seconds. See, it goes off. So it remains off. And if I press it again, it doesn't matter how fast am I pressing this button. You take a look, I may even forget my finger on the button here, like that. And you can see my finger is on the button because you see the light here associated to the button. And regardless, in 10 seconds, the light is gonna go off anyway, as you can see, even if I still have my finger on the button. And I'm gonna make this one now a bit shorter. I'm gonna make it 2 seconds. So I press it shortly. In 2 seconds it goes off. You see? I press it longer. In 2 seconds it goes off anyway. I forget my finger on the button. In 2 seconds it goes off anyway. So it does not depend on the duration I hold the button. So the triggering push button I'm using is used in such a specific way that the output stays on for a very well calculated duration. In that example here, it's easy to do because it's about PLCs, it's software programming. Let's come here closer to find out how this particular monostable circuit is working in a PLC program. Okay? And then we come back for other examples. Right here. So here, that section in the top represents the monostable. Actually, it's only this part over here representing the monostable, which is ending with the timer. The last line is not necessarily required, but I included it on purpose because I want you to be able to see the duration on the white light. And I'm using this online simulator, which is connected to the PLC. because using the online simulator, we're going to be able to figure out how it is operating. Let's take a look. Here, this push button here is called the left start. Is this left? Because I have two sets of buttons, left and right. This is the left start, the left stop, right start and right stop. And anytime I'm pressing this one here, I'm going to trigger my monostable. And we take a look. Normally this contact here is open, as you can see, because if you watch the green line, it's only conducting electricity when I hold it pushed, you see? Now, it's off at the beginning, so when I'm going to push it, it's going to quickly energize this control relay. CR stands for control relay. And even if I release it, take a look, I release it, it goes back off. A contact belonging to this coil, which is over here, take a look, is the same address, channel 12, bit 12, channel 12, bit 12. This contact belongs to this relay coil. So as soon as I energize this one, the contact is going to close. And because the contact here, whatever it is a normally closed one, even if I remove my finger from the triggering green button, the energy is going to pass through here to the output. Let's make it 10 seconds because it's going to be easier to watch, okay? So I press it. I released the finger already, but the energy passes now right here because of the holding contact. This is called the holding contact belonging to the coil. Now, why did it stop? It's because here in serious with it, there was a contact belonging to a timer, timer number 5. And the timer is over here. So what happens is this. As soon as, again, I press the green button, the energy passes here. The holding is going to keep energy passing here, is energizing the timer, but the timer is counting down. Take a look. And when it's reaching the 10 seconds, don't worry about the number 100, it represents actually 10 seconds. When the 10 seconds are gone, then any contact belonging to this timer, which was normally closed, is going to open. If it's only opening it shortly, it doesn't matter what it does after that. It goes back on. But opening it shortly is going to open that circuit here, so opening the path of energy to the output. And because of this, the coil is not energized anymore, that contact goes back off, and even if this one goes back on when the timer is not energized, what is going on again? Because when the timer is not energized, this contact, as you can see, is normally on. And you can see it here is normally on because it's green, okay? So, in the moment the contact of this timer goes off when the timer finishes to count the 10 seconds, it opens the line here, and because I removed my finger from the button already, it's going to remain off. And I'm using this last line only to show you the light, because as soon as I energize the coil, this contact here goes on, this one being already on because it's normally on. Okay? I energize the light, which is a white LED, and in the moment the timer finishes to count the 10 seconds, this one goes shortly off, cutting the line, so the light goes off. This is actually the monostable in programming in a PLC. And if you just change the addresses here according to the model of the PLC you have, and it's not only about the brand, because even for the same brand I'm using an Omron here, but it won't matter, because even for the same brand, if you change the model of the PLC, you have to change addresses here and there, they won't be the same. But the diagram is going to remain practically identical, because this is a classical diagram to make what? To make a monostable circuit in programming with a PLC. In ladder logic, by the way, okay? So now, if we go back over here on the screen, the monostable is here in the button, and if you watch the little hand going on the screen, how it is operating. As soon as the control input, which is this green button here, it goes on, the output, which is below, it goes on. So it doesn't matter for how long the input stays on, either for a long time like here or a very short time like here. The output, as you can see, it's a constant value. In the example here on the screen, it's 1.5 seconds. It won't matter because I used in my diagram a memory location. I have over 20,000 such memory locations I can use for programming. It doesn't matter. And I'm giving you 3 examples. So I put in this location depending what push button I press on my PLC. I can put one of the 3 values. It can be the 10 seconds, this one here. So now the timer takes its value 10 seconds from the memory location I stored the 10 seconds in. So in 10 seconds it goes off, see? Or I can press another one to simply make it 2 seconds. So when I press the button, it doesn't matter for how long. It only stays on for 2 seconds. Or I make it very close to what is a real life in real applications. Very short, something like 0.2 seconds is exactly the duration I'm able to press the button. I'm not able to press it faster, you see? But the light doesn't go off because I take my finger off. Because take a look, I can take my finger off much later and the light still goes off after 0.2 seconds, you see? So I won't be able to press it faster than 0.2 seconds because also the button inside it has a spring, so the duration it's taking for me to press it doesn't matter how fast, and the spring to push the green button back, it's only taking 0.2 seconds anyway. So short or long, it doesn't matter. This is a constant value, and I can modify this constant value anytime I want in the program, or if I store different values, I'm only limited by the number of buttons I have to store these values in the memory location. So if I turn it back to a longer one, it's going to be 2 seconds. Or if I press the other one, it's going to be 10 seconds. So in 10 seconds it goes off. So this is the way the monostable is working. 10 seconds and it goes off, see? So unlike the astable circuit, the monostable only goes out of its stable state off. It only goes out for the duration you establish. If you do in electronics, like we're going to do next time, then you have to calculate that duration, and we're going to see how. Here you don't have to calculate anything. You just put the number of seconds depending on the programming language you use in the timer, and the timer, using the internal clock of the PLC, is going to calculate the duration you really want. Okay? So if I'm doing it again, this is when I trigger over here a standard clock generator, or astable, or flicker, you call it as you wish, or oscillator, you know, and it's going to keep oscillating as long as the energy is on. I can stop it, and it stops. Okay. Now, for this one here, I can also give you an example of use, what you can do with that. Actually, when the duration is very short, like this one is better, 0.2 seconds. It's just another method to debounce push buttons for PLCs. And not only this, it can control something else, like now, with that signal here, I'm going to control this green light. Let's make it 10 seconds to make sure everybody understands. So now, 10 seconds later, this green light is going to start flickering. So I'm controlling with the monostable that circuit over here. I can stop it anytime I want. It's going to stop. And just for you to see, nothing is going to happen until the duration of the monostable elapses. So in 10 seconds. Only then my circuit is going to be triggered. You see? So I can stop it anytime, of course. Same thing about if you want the pump you use for your swimming pool. You program the pump, you go out, and the pump is going to start, let's say, at 10 o'clock in the morning. You're at work already. So the pump is going to work between 10 o'clock to noon, so for 2 hours. So what is the normal state of the pump? Is off. And you want it to be on only for 2 hours, between 10 o'clock to noon. So that's what I'm simulating here with my 10 seconds. And let's say I'm simulating now, I want to control the pump, you see? Okay? So, short conclusion for today, there are several ways to program a monostable circuit. And this is the most flexible one. Why? Because it allows you, by using a program on your PLC, it's allowing you to control the duration of the timer. Either you put the duration or several durations in a memory location. So by using different push buttons here, you can modify from a short one, like this. Let's not be bothered by the green light. Or a longer one, like this. See, 2 seconds. Or a longer one like this, 10 seconds. You can program this. Is the most flexible way to do it, and you're going to apply this application. Or there is another way which is actually used currently for debouncing different sensors and triggering contacts. And I'm going to show this to you right now over here. And in Omron PLCs, this is called differentiate up or differentiate down. The one which is identical practically in functioning with building a monostable like before is the differentiate up. So when I'm going to show this to you over here in the program, is a bit down in the program. See? Is right here, is called differentiate up, and I'm using a control relay in order to do this. What does it do actually? When I'm using this, you didn't even notice, because I implemented, take a look, this is the one, because you are going to see the switch going on quickly over here. You see? I press the button so the whole line becomes green. Take a look. Okay? The whole line becomes green. So this is the button actuating it. It determines exactly like you can see on the screen. It determines here a monostable, regardless the duration I hold my finger on it. But this time I don't have a direct control over the duration itself, because that particular instruction is related to the duration of an executing cycle for my PLC. As the executing cycle for my PLC is very short, the instructions are executed one by one, let's say in tens of microseconds. It doesn't take long. So the whole program, because it's a short one, is going to last maybe milliseconds. The duration of such cycle is from the moment I push the button, until the next time the cycle executing is going to find that instruction again. So it's only the duration of one cycle, which is very short, milliseconds. But it's currently used to debounce all kinds of sensors. So for today, we found two ways to make a monostable circuit. One way is pre-programmed, and this is with differentiate up or differentiate down. The difference between them is differentiate up, the output goes on as soon as you have a rising edge in other words, when I press the normally open contact, and the differentiate down is on the falling edge. So when I release the button, okay, that's the only difference between the two. And the duration, again, I cannot control myself. It's actually the duration of the program executed by the PLC, one cycle. And the standard monostable circuit you can build is the one I was showing you before, where you can program yourself the duration by playing with the duration of the timer, either in the timer itself, or if you put the duration in memory locations, you can store whatever values you have inside. Okay? Next time we're going to deal with doing a similar thing with TTL integrated circuits, with hardware programming, not software programming. Okay? So thank you very much for today. See you for the next one. Bye-bye.